Hey, this is Mr. Beckstrom, and today I want to take a look at an example from section 2-1. This is estimating a secant line from the graph. In this case, it's 6 times the cosine of x at the x value of pi over 2. So the first thing I'm going to do in this case, and this is very similar to number 6, although now we have a trig function here. That's kind of the main difference. So I want to pull up my calculator here. I'm bringing this over here, and I want to see what this graph looks like. So I am going to go into y equals. And before I do that, I should have gone into mode and make sure that I am in radian, which I am because we are talking about radians, so don't forget to do that. And then I'm going to go back into y equals, and I'm going to put in 6 cosine of pi over 2, of x. Just like that. Enter. And let's take a look at the graph there, see if we can really see it right now. And I can't see too much yet, so let's go ahead and kind of mess with the window a little bit. So what I'm going to do is I kind of want to center around pi over 2. So let's go from 0 to pi, because pi over 2 is right in the middle of that. Second pi. And this is, so whatever value you get there, we're going to multiply that by 6. So let's go from -7 to +7 on the y values. So -7 to +7, +7, and everything else should stay the same. Alright. So this gives us a pretty good idea. Pi over 2 should be right in the middle since I went from 0 to pi. So I'm looking at a negative slope that looks just like this. It looks like it's a slope that's going to be pretty close to like a -1, right? Because it looks like it's going down 1 and over 1. So that's kind of where I'm expecting to be, but it doesn't have to be that. But I just kind of want to get an idea of what I'm looking at first. Now we're going to get into a little bit more detail than we did on the last problem. Excuse me, I had a cold. So first thing I'm going to do is I'm going to take a look at the interval from, let me pull that back up here, from pi over 2 to pi. So I'm going to just kind of hand do this one. So we're going to go from pi over 2 to pi. Alright, and we're going to find out what the slope here is. Now remember, we want to find it out at pi over 2. So the pi over 2 here is never going to change. And remember, our formula for the slope, which I'm going to put over here, is y2 minus y1 all over x2 minus x1. And we're going to check this slope for each of our intervals here. I'll put them in. So since this x1 and the y1 are never, excuse me, the x1 and the y1 are really never going to change, because it's just going to be, the x1 is always going to be pi over 2, and the y1 is just going to be whatever this function is when I plug in pi over 2 for the for this value here for the y. Or excuse me, when I plug in the pi over 2 for the x and I calculate the y. If I just find those, then my real only variable is going to be the x2 and the y2. So let's go ahead and figure out what that y1 is going to be, because that's going to be a fixed one. So y1, if we plug in a pi over 2 for this value, the cosine of pi over 2 is pointing straight up. That's the x values. That's going to be 0. And 6 times 0 is going to be 0, so that's just going to be a 0 here. So that's 0, and my x1 is going to be, it's just simply that x value there. That's pi over 2. So those are easy, and then I'm going to put in some variables to represent the x2 and the y2 in my calculator. So bringing my calculator back up here. When I put this formula in, I'm actually going to put the formula for the slope in, and then that way I can calculate all of these slopes a whole lot easier. So this is going to be y2, which I'm going to calculate it this way. If I do this, I'm going to go to variables, y variables. I'm going to say when you calculate my y2, we're going to pull up my y1 function, and we're going to use whatever I put in for my x value. And we're going to change my x each time. And then we're simply going to subtract the y1, which is 0. This is the top portion of that right here, y2 minus y1. And then we're going to divide by the x2. Remember to put the parentheses around the entire numerator and entire denominator. And we said the x2 is going to be, that's just whatever variable I have for x. And my x1 is going to be that pi over 2. And I can put that in parentheses too. Second pi divided by 2. All right. So now I've got a nice little formula here that each time I change my x value, it's going to figure out the new slope of that secant line, and we'll keep bringing this value closer and closer to pi over 2 until we get something really close, and then we can make a conjecture about the slope of the tangent line as soon as we get to pi over 2. All right, so that's what we're going to do. So we're going to go back out here, and the first thing I want to do is I want to store my x value as the pi. Remember, this value never changes because that's what we're going to try to calculate it as. So it's this, we're really only changing the x2 and the y2 value. That's why we put those in as constants. All right, so I'm going to say second pi. We're going to store that as our x, enter. And then I'm going to vars, go to my y variables. I'm going to pull up that y2 function. That's where I put the slope of that secant line in there. And I'm going to evaluate it at the value that I just put in for x, which is that pi, the 3.14. And I'm going to round that to 3 decimal places, so that should be negative 3.820. Negative 3.820. I'm going to check my negative 3.820. All right, and that looks like it was good. Negative 3.820. Okay, now the next one, what I want to do is I want to move closer to pi over 2. So I want something that's not as far away from as the pi is. So I could try to do something like some value between pi over 2 and pi. I could do like a midpoint formula, like add them up, divide by 2. That would be like a 3 pi over 4. Or I could just add a really small value to pi over 2. And that'll get me closer to pi over 2 than what pi is, because pi is about 3.14 and pi over 2 is 1.57. So let's just say I added 0.1 to 1.57. That's just going to give me what, 1.67? And that's definitely closer than 3.14. So that's what I'm going to do for my next one, because I really end up wanting to get really close to it. So now I'm just going to do, we're going to go from pi over 2. And then right value, we're going to change that from pi to just pi over 2 to pi over 2 plus 0.1. So all we're doing here is just adding a little bit to it, so our secant line, or our second value, is much closer to pi over 2 than our first x2 value was. Now the nice thing is I don't have to do a whole lot of work since I kind of put that in the calculator the way I wanted it to. So now all I have to do is store my x value again. So I'm just going to do second pi over 2 plus 0.1 plus 0.1, and I am going to say enter, see what that is. Like I said, that's about 1.67. We're going to store that as x now, so that's our new x. And then we'll do the same thing I did before. I'm going to hit vars, y variable, function. We're going to run that slope formula again that's stored in y2 with the new x that we just stored. And now we get negative 5.990. Negative 5. And that is correct. So negative 5.990. All right, now let's go to the next one. Now I want this value, the x2 value, to be even closer to this pi over 2. So what's a smaller value than 0.1 that I can add to this pi over 2 on the right? I can add 0.01. That's even closer, so let's do that. So now we're going to go from pi over 2, and this time we're going to go pi over 2 plus 0.01. So now this value here is going to be really close. So if this was if this is 1.57, then this should be really close to like 1.58. So we're going to do the same thing we did before. Now we're going to do, what are we going to do? Second pi divided by 2 plus 0.01. Enter. Yep, about 1.58. We're going to store that. Store as our new x. And then we're going to go to vars, go to our y variable, and we're going to go to our y2 because that's the function that I stored as our slope formula. We're going to evaluate that as our new x, which is the new x value that we just stored. And now we're going to get negative 5.9999, which since we're rounding to 3 decimal places, that's going to actually give us negative 6.000, which I'm going to check right now. Negative 6.000, and that is correct. And now we're going to go even farther out. So as you can probably surmise by this point, if we want to go even farther out, or even closer, I should say, to that pi over 2, we're looking at pi over 2 plus 0.001. So 1/1000th. And same kind of deal here. So we should kind of get the gist of this now. So we're going to do pi divided by 2 plus 0.001. Okay, and then we are going to vars, y variables, y2, evaluated at our new x. And once again, we got a number that is super duper duper close. I feel like we got the same as our last time. Did I do that right? Yeah. So that's going to round to, if we go to 3 decimal places, negative 6.000. So negative 6.000. So if we want to do one more of these, pi over 2 to pi over 2 plus 0 point with 3 zeros, we're going to get the same thing. 0, 0, 0. You can check that on your own to make sure that you believe me. Negative 6.000. And then finally, we are going to make our guess about what the actual slope of the tangent line is at pi over 2. And as you can probably guess, it's negative 6. That's it. If you have any questions, please let me know, and have a great rest of your week. Thanks.